Hello and welcome to this video. My name is Brandon Becker, Product Line Manager of Industrial Wide Bandgap at Semiconductor. Today I'm going to share with you a video about utilizing wide bandgap in HEV and EV charging applications. Charging stations for hybrid electric vehicles and electric vehicles is one of the major focus markets and drivers of wide bandgap, specifically Silicon Carbide. In 2020, it's projected 13 million charging poles will be deployed around the world. Taking a look at a couple of the EV charging station trends, it's really evident that consumers want the equivalent time it takes to refill a car with gas the same as it does to charge a car. But a majority of existing stations are level 1 and level 2 chargers. So as power increases, the need for SiC becomes stronger. Additionally, the market is really being driven by government policies. Taking a deeper look at the different charging station levels, we can see below that a level 1 is about an 11 kilowatt charger. The time it takes is 10 hours at a slow speed, and it's one phase of AC charging which needs to go through the onboard charging unit on the car. A level 2 is a 22 kilowatt charger that takes about 3 hours at a medium speed and uses a 3-phase AC charging, again going through an onboard charger on the vehicle. A level 3 is where it changes. Level 3 is about 44 kilowatts. The time it takes is about 25 to 35 minutes, which is considered fast. This is where we get into the DC offboard charging, meaning we don't need to go through the car's onboard charger to charge the battery. And now we're even looking at ultra-fast level 4 chargers, 250 kilowatts from 5 to 7 minutes to get a full charge at an ultra-fast speed. This is ultra-high DC offboard charging, the most comparable to refilling at a gas station. What's important to note is that with a level 1 and a level 2 charger, those are AC outputs, which means that the signal going into the car needs to use an onboard AC to DC converter before charging the battery. The only way to get fast charging, a level 3 or level 4, is to get a DC output at the charging station themselves. Here we're going to take an in-depth look at the charging station block diagram. When we look at this, you have the grid, which provides AC power, going into a charging station, which converts that from an AC to a DC signal, which then can charge the battery directly, which is the real thing that enables the speed to go up. So a silicon solution is a very big charger. It's usually more mechanical with relays versus a SiC solution, which is 10 times smaller, 60% less power used during the charging phases itself, and it's able to achieve a 99% peak efficiency. One very common topology is a 3-phase Vienna PFC with a DC to DC either being a full or half bridge. The benefits of using a 3-phase Vienna PFC is that the 3 phases are actually at different voltage levels, which makes the system very, very efficient. In summary, wide bandgap is the solution to all engineers' problems. It really does 3 things. First, size reduction. The whole system is much smaller, moving from silicon to silicon carbide. Second, it's an efficiency and performance improvement, and we see up to 73% reduction in losses. Third is cost. We can see today that the cost of a system is actually cheaper at a BOM level than a silicon solution. Now that we've gone through what silicon carbide is, how it's manufactured, some of the benefits that go along with that, let's take a look at Semiconductor's portfolio. We have a very large portfolio that range from diodes to MOSFETs. Our diodes include 650 volt and 1200 volt through-hole, surface mount, die, and modules. Our MOSFETs are released at 1200 volts, with 900 volts and 650 volts coming in the near future. All of our products have high level of quality and reliability, which include undergoing AEC-Q 101 testing. Thank you for watching this video about utilizing wide bandgap in HEV and EV charging applications. Make sure to tune in to the other video series, Server and Industrial Power Supplies, as well as Solar and Renewable Energy. Also, please visit our website at onsemi.com for more information about wide bandgap and other products. Thank you.